Vsauce, Wasim here. And don't mind me, I'm just downloading Fortnite on my Nintendo Switch. Can you believe that such a huge file is coming from Epic Games server onto this device right here in one cohesive unit? Or does it? Well, no. Data on the internet are sent in packets. Not this time. Packets are units of data. They're being routed from one node to another on a packet switch network. The internet is a packet switch network. Pretty complex one at that. It has 7 different layers. So a packet needs to have a definite structure to go with the internet. But how do I explain the structure? I'm not just the guy to explain it for you, so I don't have to.
So, everybody uses the internet. If you don't, God help you. Whenever you use the internet, whether it be for streaming, googling, etc., data, the information you want, is sent via packets. Packets are tri-layered. The topmost layer is called the header. This contains the length of the packet number, the protocol, and the receiver and sender's address. So it contains all the important bits for communicating, just like your real head. The middle is called the body. Now the body contains the actual meat of your data. It has the information you're trying to send or receive. It basically contains all the vital parts. However, the size per packet is a bit small, unlike you fat. The last part of a packet is the footer. This contains a couple of bits for telling the receiver that they may have reached the end of a packet. It might also contain some types of error checking, the most common being cyclic redundancy check or CRC. The footer is the least important bit of a packet, but you do need them to move forward. Packet sizes can range from 1 kilobyte to 4 kilobytes, but a typical packet is 1.4 to 1.5 kilobytes. The most common type of packet is the TCP/IP packet. The TCP/IP is subdivided into 2 parts. As shown in the diagram here, the IP part contains both the body and the header, the version of IP, the length of the packet, and the type of service. The TCP part contains the source and destination ports, which is decoded and used by the servers and routers. It also contains the sequence and acknowledgement numbers, which is used by our devices to ensure the packet is in correct order. As there are various types of devices, ranging from phones to smart refrigerators and microwaves, the OSI or Open Systems Interconnection model was developed. In it, the transport layer uses the sequence and acknowledgement numbers to order and assemble the data for transportation. The network layer uses the destination and source ports, as well as the senders and receivers' IP addresses to deliver the packet. Off to you, Vsauce.
Well, now that you know how packets work, that's great. That packet being sent on the internet is your packet. But how much does your packet weigh? Well, to answer that question, you gotta see packets as what they really are, pieces of data. The maximum size of a packet is 66 kilobytes. Convert that to bits, and exactly half of those bits are ones which need to be stored in a capacitor. A capacitor uses 40,000 electrons to represent 1 one. So convert bytes to electrons and multiply that by the mass of 1 electron. And you get, wait for it, 0.0000000000000000096 grams. Well, that's great. If packets are just electrons, why don't we send electrons on wires instead of all this complexity? Well, to answer that question, I'm gonna need some help. Again.
Hey there, Seth here. In reality, what Vsauce is describing is more akin to circuit switching than it is to packet switching. Let's take a quick overlook over what circuit switching does differently than packet switching. Circuit switching establishes a physical path between the sender and the receiver of the message before the actual message is delivered. It implements at the physical layer, unlike packet switching, which implements at the network layer. Circuit switching can be explained with the example of a telephone conversation, which means that the connection between the caller and the receiver remains connected until the whole conversation is done and dealt with, and both the caller and the receiver hang up their phones. The circuit switching is not appropriate for data transmission because data is transmitted in a stream. It is not always needed, not always online, and most of the time it remains idle, and only when the data is being transmitted is it is used. which means that if circuit switching was used for data transmission instead of packet switching, the actual bandwidth would be wasted and your money would go down the drain. Packet switching, unlike circuit switching, is connectionless because it does not establish any real physical connection before the transmission starts. Before the message is transmitted, it is divided into small, manageable parts called packets. These packets are routed one by one from source to destination, from a user to the receiver. In packet switching, each packet may follow a different route to reach the destination. And unlike circuit switching, network layer, or which is basically virtual, it is not a real thing, and there is no dedicated line for between the user and the receiver for the actual data to be transmitted. Back to you, Vsauce.
Thank you,
Seth Blong.
Very cool. You know, I realized something today while learning about packets. We're not so different, you and I, from packets. They carry data, and we carry data too, our experiences. And we pass them on to the next generation, the next node, to say. So the next time you're surfing on the internet, think of the packets, the little guys at work. And as always, thanks for watching. Thanks to Seth Blong and Unformally Explained for being in this video, and an even more special thanks to my brother for recording all of this. But even a bigger special thanks to Audible.com! This video is sponsored by Audible.com. Go to www.audible.com/vsauce to get a free 30-day trial of any audiobooks of your choice.